Okay, so for our code overview on Lab 3, we're going to cover two simple modules we made. One is a counter LED iterator, and one is a 7-segment display that just counts up to this number here. So Chuka's going to go first with the counter LED.
So the counter LED module, what it does is it uses the clock function, and it assigns different registers to different LED values for the timers. And what it does is it increments a 32-bit counter and continuously resets it, giving it different colors at different intervals, which appear to be random. And for Taylor with the 7-segment.
Okay, so for the 7-segment counter, we are taking in a clock and a reset button, and we're going to output onto an anode and LED. Most of this code here is just checking for the reset. If that's reset, to reset it back, such as the second counters. Here's where it iterates through the counter. This is going to check if the display number needs to be resetted. Down here, we're going to check to see if the refresh counter needs to be reset. The refresh counter is what is used during the LED activation. So now we're going to check here to see if a new LED is going to need to be changed on the 7-segment display. This uses regular division into modulus and divisors, and these give us a binary result for our cases down here. And so in our LED cases, we just go and check through and assign based on what we're receiving in as our LED BCD. The assignment then goes on to the 7-segment with the default case being a 0. So for some of the basic features on the FPGA that we integrated during our Lab 3, we have the sequential counter here on the 7-segment, which can be reset using the middle button, and that'll reset it back going up each second. We also have the RGB LEDs, which are being randomized based on a constant counter, so it's not actually randomized, it's just being changed very quickly. Outside of that, we also have audio, which just outputs a constant blaring noise that changes based on what inputs are given here, changes the note. We tried to do the VGA, it did not function, so that's why we added so many other features outside of that.
We also made the ALU display on the LEDs, and we made the mode function 4-bit. So the first 4 switches are our A inputs, the next 4 are B inputs, the next 4 are modes. No, this is the carry-in, and the next 4 are modes, and the last 3 are up functions. So for example, the AND function is the first one. So if you have the first 2 and the next 2, that's AND. And then we could also try the OR function. Another one we could try is the XOR function. And so on.
All right, well, we can call this for Lab 3, our design was to change the increment and decrement features on the FPGA board, as well as implement some new features, such as a counter on the 7-segment, a input onto the VGA, modifications of the RGB LEDs in slots 16 and 17 on the board, and also use buttons to feature some sort of sequential logic. For the coding portion, the most interesting thing to me was the 7-segment. Using the logic trying to count up to 999 seconds required a lot of modulus and devising operators, and the conditional statements were quite interesting.
And for the ALU segment, the interesting part was adding a lot more arithmetic and logical functions using different gates.
Okay, yeah, that's good.